Hello everyone. Through orthographic projections, we are going to learn how to make the two-dimensional drawings like plans, elevations, and sections of various objects. Once you know this skill, you can apply it in making building drawings, building plan, building elevation, building sections. Although today we are in a time when drawings are made digitally, but still the skill of understanding how these elevations or how these plans or sections are made, that is very important. Therefore, we are going to go through this exercise of making these two-dimensional drawings by the way of using orthographic projections. So there is this box that we have. We can call it a box or a cuboid. If you want to make the plan of it, that means we have to look from top. If you want to make an elevation of it, that means we'll have to look from the front. If I want the side elevation, then for example, if this is the side elevation, that means I'll have to look from this side. And if there is another side elevation, then we have to look from the other side. We can also have a back side elevation, and we can have an elevation, we can have a plan from the bottom. Generally, we would have elevations of all four sides, and plan is only from the top. So there is no bottom view. Now we assume that this box is somewhere in relation to two planes. What are these two planes? These two planes, the vertical plane and the horizontal plane, which are crossing at this green line, which we will term as the XY line. It has four quadrants. This is the first quadrant, which means this vertical plane and this horizontal plane. This vertical plane and that horizontal plane makes the second quadrant. This horizontal plane and the lower vertical makes the third quadrant, and the lower vertical plane and the front horizontal plane makes the fourth quadrant. So these are known either as quadrants or dihedral angles. How are these planes useful? First, let us understand. So for our purpose, we are going to do things in the first quadrant only. Now for me to be able to make the plan or the top view of this cuboid, I will have to take my projections down to the horizontal plane. Why do we call them orthographic projection? Orthographic projection because from these edges, we take perpendicular lines down, whatever might be the angle or the placement of the object. If I can achieve this point and this point, joining these two, I can achieve this line. So whatever is the angle at which these objects are placed, we take down lines which are perpendicular to the lower horizontal plane or the vertical plane which is out here. Let me first name them. This is the horizontal plane or HP. This is the vertical plane or VP. So now three things which you will always remember as we go ahead is there is this XY line around which we have horizontal plane here and vertical plane there. And if I could drop this vertical plane down, then I'll get the XY line. XY line will be here, horizontal plane and vertical plane. This we will use for our drawings. So I will drop down lines, perpendicular lines from the corners of these to be able to achieve my plan. So how do I do that? And as these vertical lines hit the horizontal plane below, my plan becomes like this. Now, if I was to translate this into a drawing, I would have this X Y line. My cuboid is at a certain distance from the vertical plane and at a certain distance from the horizontal plane. If I was to make it from the top, the cuboid has various faces. This face is visible above the horizontal plane. This face is visible in front of the vertical plane. Therefore, it is visible in front of the vertical plane. This is same as the top, which is projecting on the horizontal plane. This is same as the front, which is projecting on the vertical plane. So if I take the projection line here, so this is this one, this is this one in front of the vertical plane. Where are my projection lines? So, orthographic projections help us to create two-dimensional drawings. That is, in this case, so the three-dimensional situation has been converted into plan or top view, front view or the elevation. We were going to use this technique to make the different views of various objects starting from a point, line, so on and so forth. So we will give the distance of the object from the horizontal plane, the distance of the object from the vertical plane, the thickness of the cuboid, the width of the cuboid and the length of the cuboid. This is our first exercise. Let's first make the 3D of this. This is the XY line. This is the horizontal plane. This is the vertical plane. When we will open it up, it will become XY line. Now we will not have the restriction of the boundaries of vertical plane or horizontal plane. Below we have the horizontal plane, above we have the vertical plane. This is a point. I have made it bigger just to exaggerate it so that it is visible. Otherwise it's just a point which does not have any dimension. This is at a certain distance from the vertical plane and at a certain distance from the horizontal plane. So now I have given it the values. It is 10 mm away from the vertical plane and 20 mm away from the horizontal plane. And we have to take the projections down to get its plan on the horizontal plane, and we have to take the projection perpendicular to the vertical plane to get its elevation on the vertical plane. So if I take the projections down, this is where the plan will come and this is where the elevation will come. So let us translate this into a two-dimensional drawing. We have the XY plane, we have the horizontal plane, we have the vertical plane. The point is 20 mm above the horizontal plane. It is 20 mm above the horizontal plane. This is where it is. So I took the point at a distance of 20 mm from the horizontal plane. From there I took down the projection and continued it. On this line I took a distance of 10 mm, which is the distance of the point from the vertical plane. And at this point I got this plan. So this is my plan and this is my elevation. This is the XY line. This is the distance of the point from the horizontal plane. This is the distance of the point from the vertical plane. We can relate it with this. Let us revise. This is the XY plane around which this is the horizontal plane, this is the vertical plane. We have opened this vertical plane, made it straight. So now we have vertical plane above and the horizontal plane below. This is the XY line which is similar to this. The point is 10 mm away from the vertical plane and 20 mm away from the horizontal plane. So I took any one of the dimensions. From the horizontal plane I took 10-20 mm and made this point. I brought down the projectors and crossed them below into the horizontal plane. On this line I took 10 mm and cut it with my parallel bar and I made this point. So this is the elevation of the point. This is the plan of the point. These are the two distances which define the location of this point from the vertical plane and the horizontal plane. So this is how we will make the plans and elevations of various objects using orthographic projection. Please go through this video as many times you like till you understand the concept.